Let's see open loop control of DC motors using the Arduino. This is the Arduino board. These are the DC motors which are connected to the circuit which are having the diodes. These diodes help in controlling the flow of direction of current. Now we can see the PWMA of the motor driver is connected to IO4 pin of Arduino, and the IO6 pin and IO4 pin of the Arduino are interconnected because one will have the high volt, that is 5 volts, and other will have 0 volts. Because we are controlling the rotational speed of the DC motor, so that we should also, to control the speed of the DC motor, we should control the voltage of the input. Because as the Arduino has only 0 or 5 volt source pins, we are using the analog source so that we can increase and decrease the value of voltage by the average method. Let's see the source code. I have declared a variable PWM of int data type, and I have initiated the value 80. In the setup code, the 12, 8 and 6 pins are given for the output, and the 12 pin is of high volt and the 8 pin is at the low volt. Now coming to the loop source, I have written analog write 6 PWM. To the 6th pin we are giving the analog signal of value PWM, that is 80. Now let's build the source code. Okay, it is already compiled. Now let's run the simulation. Now we can see the value of the speed of the DC motor is increasing. As we are running the simulation, real-time values of the DC motors cannot be shown, so that it is going through the process. The value of the RPM is increasing and will come to the stationary point after a minute. So to control the rotation of the DC motor, we can control using the values of PWM. The PWM is pulse width module, so that from 0 to 5 the voltage will be controlled using this PWM value. Now let's see using the Node-RED software. To run the Node-RED software, let's open the command prompt and type node-red. It will start the server of Node-RED. We can see the IP address 127.0.0.1 and the port 1880. Let's minimize and open a browser. Now let's type 127.0.0.1:1880. We can see the interface. Now let's form a sequence, that is, from the dashboard let us drag a slider, a gauge and a chart. Now let's connect the slider to the gauge and the chart. Now let's double click to change the settings. The group is water level. Now let's rename it as water level slider. And from 0 to 100 in steps of 1. Done. And now let's rename the gauge water level from 0 to 100. Now let's give the coloring code. From 0 to 40 it will be green, from 40 to 80 yellow, and 80 to 100 is red. Now coming to the chart, water level. Now we will give the chart as bar chart. Now let's indicate minimum and maximum value 0 and 100. Done. Okay. Now deploy it. To open the user interface, we have to type the server IP address /UI. UI represents the user interface. Now we have opened the user interface. As we increase the water level slider value, the graph and the water level gauge is also increased. Now in the real time, we can see as we move the slider to and fro, the value of the gauge and the chart is being changed.